Hello everyone, I'm Aditya, faculty at ACE Engineering Academy. In this video, I'm going to solve CSE GATE 2022 questions from Engineering Mathematics. Have a look at the first question. A function y of x is defined in the interval that is 0 to 1 on the x-axis as follows. Okay, so it's a piecewise function they have given to us. What are they asking? Which one of the following is the area under the curve for the interval 0 to 1 on the x-axis? They are asking what is area under y of x. Okay, now for that what you can do is you can first draw what is y of x. So it's defined like this. In the interval 0 to, okay, let me mark this point like 0, this is 1 by 3, this is 3 by 4, and then let's say this is 1. In the interval 0 to 1 by 3, it is defined as 2. Okay, so let's say this is 2. In the interval 1 by 3 to 3 by 4, it is marked as, or it's given as 3. Okay, let's say this is 3. So this is 2, this is 3. And in the interval 3 by 4 to 1, it is given as 1. Okay, so now what I see is, I see 3 rectangles here. So rectangles like what? So it's a rectangle like this. This is another rectangle. And this is another rectangle. What are they asking? Area under y of x. So this is y of x. You simply add areas of all the 3 rectangles to get the answer. So what's the area of the rectangle? For example, let's say this is the length and this is the height. So this is simply length into this height. In the same way, add the other areas. So let me find areas of the rectangle. So this length is 1 by 3 and this is 2. So this is 1 by 3 into 2 plus. Now how much is this? You need to take the difference like this, 3 by 4 minus 1 by 3 into how much is this? This height is 3 units plus this difference, that is 1 minus 3 by 4 will be the length. Okay, so 1 minus 3 by 4 and then into what? Into 1. If you simplify this, that's the answer. Such a simple question was asked for 1 mark. So what I'll do is I'll write like this. This is 2 by 3. Now you need to take the LCM, so it's 9 minus 4 here. So it's 9 minus 4 by 9 minus 4 by 12, and then here it's 1 minus 3 by 4, and then I have to multiply here with 3. Okay, so into 3, and then this is 1 minus 3 by 4 is 1 by 4. Now let's simplify. What I'll do is I'll make sure that the denominators are all 12 so that my simplification gets easy. So this is some let's say multiply 4, so this is 8 by 12. And then this is 5, right? 5 into 3 is 15. So it's 15 by 12. And then I'll make sure the denominator is 12. For that, I'll multiply with 3. So it's 3 by 12. Now you can add it. How much is this? So this is 23. 23 plus 3 is 26. 26 by 12. So 26 by 12. After simplification, you get 13 by 6. Do we have option like 13 by 6? Yes. So the answer for this question is 13 by 6. Let's go to the next problem. What are they asking? Let r be a root of the equation x square plus 2x plus 6 equal to 0. Then the value of the expression, that is r plus 2 into r plus 3 into r plus 4 into r plus 5 is dash, and various options are given. So how do you solve this question? What I'll do is I'll first multiply these two terms. I'll multiply these two terms. What is r plus 2 into r plus 3? It is r square plus, so this is like 2r, and then this is like 3r. 2r plus 3r is 5r, and then 2 into 3 is 6. So when you multiply, you get like this. And this is r square, right? So this gives you 4r, this gives you 5r, which makes this as 9r plus 4 into 5 is 20. Now he clearly said r is a root. Okay, so when r is a root, you can put r into this equation. You get a condition in r, that is r square plus 2r plus 6 will always be equal to what? 0. So this will be the turning point in this problem. So wherever you have this, you can put 0. Wherever you have what? R square plus 2r plus 6. Now what I'll do is I'll make sure I'll write this in terms of r square plus 2r plus 6. So how do you do that? So it's r square plus 2r plus 6, and then what is left here? 3r is left. Okay, now in the same way I write this also in the same way, r square plus 2r plus 6. So what else I have to write here? I have to write 7r and also 14. Now I would like to highlight this part. Now instead of this you can put 0, instead of this you can put 0. So what is left? 3r is left here, and then what is left here? 7r plus 14 is left. Now you see that 7 is common here and there is a 3 here. It's 21, and then I'll send r inside, so this becomes r square plus 7 came out, so it's 2, so it's 2r, right? Now the final step, r square plus 2r. Now according to this equation, what is r square plus 2r? R square plus 2r is simply minus 6. You can use that, so the answer is 21 into minus 6. 21 into minus 6 is obviously minus 126. So that's the answer for this question. Let's go to the next problem. Consider the following two statements with respect to the matrices A, B, C, D. What is A? It's a M cross N matrix. B, N cross M matrix. C, N cross N. D is also N cross N. Statement 1 talks about trace of AB equal to trace of BA. Statement 2 talks about trace of CD equal to trace of DC. And he clearly says this notation, that is TR, represents trace of a matrix. Which one of the following holds? And various options are given. Okay, so ultimately what we have to do is we have to verify what is statement 1 and statement 2. Is the statement 1 true or not? Statement 2 true or not? So statement 1 talks about trace of AB equal to trace of BA. We are all aware of what is trace of a matrix. Trace of a matrix is simply trace of a matrix is simply sum of principal diagonal elements, right? So for that you need to find AB and then BA, then take their traces and then compare. Okay, so I have this activity in front of me. So this is like A. Okay, so what is this? This is like A. This is the matrix A. This is matrix B. The order of A is given in the problem as M cross N. Look at this. First row, second row, so on, M rows. So this is M cross N. And the order of B is N cross M. That is N rows. 1, 2, so on, N rows. And M columns. So this makes this N cross M. So now what are we supposed to do is find AB. Okay. So when you find AB, what happens is you get a matrix of what order? M cross N. Okay, you have to imagine it like this. You get a matrix of order M cross M. You need to find trace of this matrix. The trace of the matrix deals with all this principal diagonal elements. If you can find this, it's simply adding all of them. So look at this, how this is going to work. I'll explain. If you solve statement 1, statement 2 is just a special case of statement 1. So now the question is, how do you get this particular element? If you want that particular element, you have to multiply this first row of A with this first column of B. So carefully try to multiply them. So what you get is A11 into B11 plus A12 into B21 plus so on A1n into Bn1. What is this? This is the element that is here. And you should find this and add them. So now I'm going to add next with this element. So how do you get that element? The second row of A multiplied with the second column of B. So what do you get? So you have to multiply it little carefully. So this is A21 multiplied with B12 plus A22 multiplied with B22 plus so on. And then this A2n multiplied with Bn2, and then like that you have to add all those, and let me write the last element, that is this. Okay, so it's an interesting problem actually. So this row into this column will give you this particular element. So let's multiply that. Am1 into B1m plus Am2 into B2m plus so on Amn into Bnm. Okay, so what is this? This is the trace of AB. In the same way, if you can find the trace of BA, we are done with this problem. Okay, so I'm now going to find the trace of BA. For that you have to write B first and then followed by A. So look at this. This is like B. Okay, so this is like what? B. This is like A. What is the order of this? It has got n rows and m columns. It has got m rows and n columns. When you multiply n cross m with m cross n, what are you going to get? You're going to get n cross n. So it also has the principal diagonal, right? If you can find them, you can add and then compare with this. We are done with this problem. We are actually doing a very simple activity. It's not at all a complicated mathematics, a simple activity. So now, how do you get this element? Now for that, I have to multiply the first row of this matrix with this first column. So let's see this. B11 into A11 plus B12 into A21 plus so on B1m into AM1. This is this element. And then we'll say plus what? Plus this particular element. For that, the second row multiplied with this second column. So what you're going to get is B21 into second column is A12 here, and then B22 with this particular element, that is A22, plus so on B2m with this element, that is AM2, right? That is this element, plus so on, and then this last element. Let's see. Now, how do you get this last element? For that, you have to multiply this row with this column. So this finishes our problem actually. So Bn1 into A1n plus Bn2 into what? A2n plus so on Bnm into Amn. So when you add this, you get trace. I just put dot 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 here, right? So now let's compare this with the earlier trace. I have A11 into B11 plus A12 into A12 into B21 plus so on this. Now try to understand this or try to observe this. Now whatever you see here, whatever I highlighted, A11 into B11 plus A12 into B21, the same thing is appearing here. A11 into B11, yes. A12 into B21. So where is that? A12 into B21, A12 into B21, yes, it's there, and so on. A1n, Bn1, right? So A1n, Bn1. So yes, A1n, Bn1. So whatever you highlighted like this is now appearing this way, right? Whatever I highlighted there, it's appearing here. Now whatever is here, the same thing is appearing here in this form, okay? That means I can now tell that trace of AB is equal to trace of BA without any doubt. So this is true for A of order m cross n and B of order n cross m. Now as a special case, what happens is, whenever you have C and D of same order, even then this really works. Therefore, the answer for this question is both the statements are true, right? So where is that option where it says both the statements are true? It is option C. So the answer for this question is option C, right? Now what you have to learn is trace of AB is always equal to trace of BA. That's the property we usually teach in the classes. So in the exam, if you already know this, it's a fraction of second. You can even go for verification, okay? In the exam, you might not get this idea, then you can start verifying the options, okay? Or you can take some matrix A, matrix B, and then you can start verifying, okay? That might also help you. So this is how I have solved this. Let's go to the next problem. Now it's a very simple problem which is based on L'Hospital rule. So what we usually do here is we apply the limit. So when you apply the limit to the numerator, what happens is you get 0 whole divided by 1 minus e power 2 into, that is root 0 is 0. So e power 0. 0 by e power 0 is 1. 1 minus 1 is 0. What you get is 0 by 0 indeterminate form. Now when you get 0 by 0 indeterminate form, what we usually do is we use L'Hospital rule, that is take the derivative of the numerator and the derivative of the denominator. So let's take the derivative of the numerator and denominator. So what happens? The derivative of the numerator is 1 divided by 2 root x, and then the derivative of the denominator is 0 minus, now this is like e power something, so the derivative is e power 2 into root x into, what's the derivative of 2 root x? The derivative of 2 root x is 2 and then the derivative of root x is, it's like this, 2 root x. Okay, so firstly the derivative of e power a root x, right? So you have to do this differentiation carefully. The derivative of this quantity, that is e power 2 root x, is e power 2 root x into 2 by 2 root x. Okay, so let's see any cancellation is there. So this completely gets cancelled with this. Okay, now you apply the limit. When you apply the limit, what you get is 1 divided by 0 minus 2 e power 2, that is 2 into 0, and then there is also a 2 here. So now e power 0 is 1. The final answer for this question is minus 1 by 2. A box contains 5 balls of same size and shape. 3 of them are green and 2 of them are orange. Balls are drawn from the box one at a time. If a green ball is drawn, it is not replaced. If an orange ball is drawn, it is replaced with another orange ball. First ball is drawn, what's the probability of getting an orange ball in the next draw? So let's look at the total objects in this box. The total objects in this box are 5. Now among this 5, 3 are green, okay, 3 are green and 2 are orange. Now he gave some keywords like, if green ball is drawn, it is not replaced. What is the meaning of this? So let's imagine that there are 5 objects. Suppose you have randomly drawn one object, and if it is found green, what are we doing is, we are putting this aside. That means the objects that are left over are 4, right? Because you have put this aside. That's how the description is given. What are you next doing? So if an orange ball is drawn, so instead of green, let's say if you have drawn the orange ball, what's happening? It is replaced with another orange ball. So let's imagine something like this. There are 5 objects, okay, 5 objects. Among them, 3 are green, 2 are orange. You have randomly drawn one ball and you found that it is orange. So what are you doing next? You are replacing this particular orange with another orange and you are placing back in the box. That means if you draw orange, again, how many objects are there? There are again 5 objects in which 3 are green and 2 are orange. So that's how this problem has been given to us. So with this data, what is he asking? What's the probability of getting an orange ball in the next draw? Okay, so we are supposed to find the probability of drawing an orange ball in the next draw. So let's write like this: the probability of drawing orange in next draw. So this is what we are supposed to find, orange in the next draw. The probability of drawing an orange in the next draw depends on what you have drawn in the first draw. So I'm going to condition this. I'm going to write like this: the probability of drawing an orange ball in the next draw is given as follows: orange in next draw given green in the first draw, green in first draw into the probability of drawing green in the first draw, green in first draw. So this is called conditioning, okay? Plus, let's write like this: the probability of drawing orange in the next draw, orange in next draw, given orange was drawn in the first draw, given orange was drawn in first draw, into the probability of drawing orange in the first draw, orange in first draw. So this is called the total probability. So I have written the total probability using the conditioning, okay? So now how do you read this particular probability, right? I'll read it like this: given green was drawn in the first draw, what's the probability of drawing orange in the next draw? So now look at this. It's given that green was drawn in the first draw. So initially 5 objects were there. You have drawn one object and it was found to be green. So when you have found it to be green, we put that aside. So how many objects are left? Only 4 are left. So in the next draw, what's the probability of drawing orange? It is so simple. It is, how many oranges are there? 2. I just want 1. So it's 2C1 by how many are left, or how many are in total? It is 4. I want to draw 1. So it's 4C1 into, right? So I wrote the probability of this. What is this? The probability of drawing green in the first draw, right? So initially there are five objects and you want to draw one green. And how many green are there? 3 are there. So because of that, it is 3C1 by 5C1. So I'm done with this first term. Let's look at the second term. So how do you read the second term? Given orange in the first draw, okay? So whatever you have drawn the first draw, you found it to be orange. So when you found that to be orange, what are you going to do? You're going to replace that orange with another orange. So the total number of objects in the box are again 5, among which 2 are orange, 3 are green. So what's the probability of drawing orange in the next draw? So in the next draw, total objects available are 5 and 2 are orange in them. So it's 2C1 by 5C1 into, what's the probability of drawing orange in the first draw? So when I talk about the first draw, so what's happening? There are 5 objects and you want one orange. So it's 2C1 by 5C1. If you simplify this, that's our answer. So let's simplify this. What do we get? You get 2 by 4 into 3 by 5 plus 2 by 5 into 2 by 5. So what's common here? I can take 2 by 5 out. So 2 by 5 is out. What is left here? So 3 by 4 plus 2 by 5. So let's take the LCM. So if you take the LCM here is 4 into 5, which is 20. So I'll multiply 5 here, so it's 15, plus I'll multiply 4 here, which is 8. You simplify this. So this cancels this by 10. So it's 23 by 50. So do we have such options? 23 by 50? Yes. So the answer for this question is 23 by 50. Consider solving the following system of simultaneous equations using LU decomposition. 3 equations are given where L and U are denoted as follows. L is a lower triangular matrix, U is a upper triangular matrix. Which one of the following is the correct combination of values for L32, U33 and X1, right? So we have an interesting question on LU decomposition. Now they are asking you some specific values like L32 and U33, okay? It's a 2-mark problem. So let's see how do we solve this question. Now the first and the foremost thing that we have to do is write the coefficient matrix. So what's the coefficient matrix? You have to pick the coefficients like 1, 1 and then minus 2, 1, 3, minus 1 and then 2, 1, minus 5, okay. So this is A. We need to reduce this A to row echelon form using only type 3 operation, right? So this is the procedure that we follow for finding the LU factors. So the first step that I write is, I want to make this element 0 as well as this 0 using this particular element. So it is R2 replaced with R2 minus 1 times R1, okay. That means I'm just subtracting this 2. What next? Let's eliminate this. R3 is replaced with R3 minus, so I have to multiply 2 to this. Multiply what? 2 to this, 2 times R1. Now in this LU decomposition or LU decomposition, the most important step is, what is that factor you are multiplying to this R1 to eliminate this value. For example, I'm multiplying 1, right, a factor called 1 to this R1. This highlighted element actually goes into the matrix L. Same way, what is that you are multiplying to R1 and then you are making this 0, okay. So that is nothing but the element 2. So the highlighted elements play the crucial role because they are now the elements in the matrix L, which is a lower triangular matrix. Let's see what's happening here next. Row 1 is retained, 1, 1, minus 2. It's like R2 is R2 minus R1, na? So it's 0 here, 3 minus 1 is 2, minus 1 plus 2, minus 1 plus 2 is 1, and then 2 minus 2 is 0, it's 1 minus 2, 1 minus 2 is minus 1, it's then minus 5 plus 4, minus 5 plus 4 is minus 1, okay. So what next? The next thing is, using this element, I'll make this 0, right. For this, what I'll do is, I'll write R3 is replaced with R3, okay. So look at the way I'm going to write this, R3 plus 1 by 2 times R2. Okay, so with this, will this element really become 0? Yes, it's minus 1 plus 1 by 2 times 2. What is 1 by 2 times 2? It's 1. So it's minus 1 plus 1 is obviously 0. But the interesting step here is, I'll rewrite this, the same equation like this. R3 replaced with R3 minus of minus 1 by 2 times R2. So what is that factor? I'm multiplying with I'm multiplying that with R2 and then subtracting from R3 to make this element 0. And that factor is minus 1 by 2. Now this plays the crucial role. This goes into the elements of L. So let's see what's happening here. The final step, that is 1, 1, minus 2. The second row is also retained, it's unchanged, 0, 2, 1, and then 0, this is 0, and then what? Will I write this clearly? Minus 1 minus 1 plus 1 by 2 into what? 1, right? See here, R3 is replaced with R3 plus 1 by 2 times R2. So it's minus 1 plus 1 by 2 times this element. So how much is this? Is it minus 1 by 2? Yes. So this is minus 1 by 2. Now this is in row echelon form. This is in row echelon form. Now whatever matrix you got, that is U. What is that? That is U, which is upper triangular matrix is talking about. And he also is asking, what is U33? U33 is minus 1 by 2. U33 is minus 1 by 2. What else we need to find? The elements of L. The elements of L are already highlighted here. Okay, the elements of L are already highlighted. It's a very simple step now. So let's write that simple step. I'm going to write the elements of L. So before that, you must know that the principal diagonal elements are all ones. So this is 1, this is 1, this is 1. Since it's a lower triangular matrix, this is 0, this is 0, this is also 0, and you're just supposed to fill these elements now. And among them, you need this particular element. That's it. Okay, now how do you write these elements is, what was that coefficient that you have multiplied with R1 and then subtracted from R2 to make this 0? What was that constant or the coefficient? It was 1. So that 1 actually goes here. So I'll write it in a different color. This is 1. Next, what was that coefficient you have multiplied to R1 to make this element 0? So that is 2. That actually goes here. Right? So we are done with the first step. Look at the second step. What's the second step? Now I want to make this element 0. I want to make this element 0. So what is that coefficient you have multiplied to R2 and then subtracted from R3? Subtracted. All the time this subtraction is important. So what was that coefficient? It was minus 1 by 2. So that minus 1 by 2 goes here. Okay. So now what is U33? We are done with this question, with this 2-mark question. What is U33? U33 is simply minus 1 by 2. What is L32? It is also minus 1 by 2. Let's look for the options. So what are options telling? Is there any option with U32 as minus 1 by 2 and U33 as minus 1 by 2? Right? I can eliminate this. I can eliminate this. I can also eliminate this. That means through elimination, the answer for this question is option D. Right? So this was a 2-mark problem. Let's look at the next problem. Right? So this is the last problem from engineering mathematics. It's a 2-mark question. Which one of the following is R? When he says is R, it's a multiple select question. It's a MSQ. The eigenvectors for the matrix given below. So some matrix is given. Let's say this is A and some eigenvectors are given. So which of these options are really the eigenvectors of the matrix A? What we usually do is, right, it's a very standard question. Right, any vector x and a scalar lambda satisfying this particular condition are called the eigenpair of A. Right, you just have to go for the verification, multiply this A and x. If you get some scalar times the same x, then x is the eigenvector. So I have now the verification. I'll start with option A. So I have taken this A and this is the vector that is provided in option A. So let's multiply this. So when I multiply, what do I get? I get 9 minus 6 and then minus 4. It's 9 minus 10, which is minus 1. Right? So you just have to multiply. This is a simple verification process. It's 8 minus 6 and then minus 1. How much is this? 8 minus 7 is 1. And then minus 20, okay, and then plus 15 plus 5, it's 0. And then minus 32, okay, plus 21, and then plus 12. So this is 33 and then this is minus 32, it's 1. Okay, so when I multiply this with this, I'm getting this. Now, when I compare this with this, so this is like AX giving me 1 times X. That means clearly X is our eigenvector for the given matrix. See, option A is okay. No issue with option A. Option A is right actually. Let's verify option B. So I have taken the second vector given in option B, again the same thing, that is AX. So let's see what happens. This row into this column. So what we get is minus 9 plus 2, right? Minus 9 plus 2. How much is this? Okay. So let's see what happens here. Minus 9, okay, plus 2 is minus 7. Next, minus 8 plus 3 is like 5. Okay. And then what's this? 20 minus 8 is 12, right? It doesn't look like the eigenvector. So it's 32 minus 7, which is 25, right? Now see this. This is AX. You can't take any element common. If you take any element common also, you don't get the X back. So this option is eliminated. Let's look at the next option. Now this is the vector that is given in option C. Let's verify it. This row into this column. So what this gives you? 9 minus 4 minus 8. So this is minus 12 and then plus 9, which is minus 3. Next, 8 minus 6 minus 2. So this is 0. Next, minus 20 plus 16 plus 10. Okay, 26 minus 20 is 6 now. Last element. So this is minus 32 and then plus 14 plus 24. 24 plus 14 is 38. 38 minus 32 is 6. So do we have any element common here? We have 3 common. If I take 3 out, so now what's left? Minus 1, 0, 2, 2. So now this looks as if it is AX giving us what? 3 times the same X now. Minus 1, 0, 2, 2 is the vector that we have taken. So definitely it's a eigenvector. Okay, it's an eigenvector. So option C is true. We are left with option D. It's a 2-mark problem, MSQ. So it's a very simple activity that you have to do. So now what are you supposed to do here? Same process. Minus 6 plus 6, this is 0. And then what? Minus 6, okay, plus 9, how much? It's 3. And then 15 minus 24. So how much is 15 minus 24? It's minus 9. The last element, 21 minus 21, it's 0. So do you have any element common here? I can take 3 out. So if I take 3 out, 0, 1 minus 3, 0. 0, 1 minus 3, 0 is the vector that you have taken in the option D. So this is satisfying this condition, that is AX equal to 3 times X. Yes, it's also the eigenvector. So D is okay, C is okay, B is not okay, A is okay. So what are the correct answers? A is okay, B not okay, and the remaining are all okay. So this is not okay, this is okay, this is okay. These 3 options you will enable in the exam. So that's it from engineering mathematics.